So today we're going to kind of bring it back full circle. We started with graphing parabolas and we're going to end graphing parabolas. However, today, instead of graphing single parabolas, we're going to be graphing single quadratic inequalities and also systems of inequalities. So the actual graphing part is very, very similar to what we did in section 5.1. So we've got some additional steps because of the inequality part. So when we start out, first thing that we want to do is we want to determine if our function is going to be dashed or solid. So the function, this is the same as what we did when we graphed linear inequalities, that we do dash solid, and we're going to do some shading. So it's going to be dashed if you have a less than symbol or a greater than symbol. It's going to be solid if they have the equals, so less than or equal to, greater than or equal to. Then you're going to graph the function. So the equation can come in many forms. We studied all of these in 5.1, so standard form, vertex form, and intercept form. Now just to remind you, regardless of which form they give you, you have to be able to find the vertex, because even if you're allowed to use your calculator to graph it, you have to know where the vertex is. So in your 5.1b notes, we talked about this more if you need to review that, but just for a quick reminder, in standard form, we find the vertex by doing opposite of b over 2a. In vertex form, the vertex is at hk, so we change the sign for the x value, we keep it for the y. In intercept form, you do p plus q divided by 2 to find the x coordinate of the vertex, and then plug in to get the y. So we do the dash solid, we graph the parabola, same rules apply as did in 5.1, so you have to have the vertex and then try to get 5 other points. If only 3 fit, then 3 will work. But then we have to add step 3, and that is we have to be able to test a point. So if we want to show all of the solutions, we have to be able to shade the appropriate region. And when we shaded linear equations, this was easy because less thans you shaded below, greater thans you shaded above. With parabolas, it's not that black and white. So in order to decide which part is shaded, we are going to pick a point inside the parabola and plug it in. If we get a true statement, so true is going to be shade inside. If it's not, meaning if the statement is false, we are going to shade outside. Remember that when we're doing a system, so when we've got more than one inequality, the solution is going to be the overlap of the two shadings. All right, so let's look at a little bit of this in action. So right now we're working on the first learning goal. I can graph quadratic inequalities, and that's example 1a. So as I look at this, I decide, is this going to be dashed or solid? And because I've got an equal sign, I am going to say that this is going to be a solid parabola. Then I need to graph the function. This is in standard form, so I'm going to do opposite of b, so opposite of 4 over 2 times a, which is -2. So that gives me -4 over -4, which is +1. So I plug that in to find the y coordinate, so -2 times 1 plus 4 times 1 plus 5. So -2 plus 4 is 2, plus 5 is 7. So 1, 7 is going to be my vertex. So I'm going to go ahead and put that on. So 3, 6, 7. Here's where my vertex is. And because the a value is negative, I know this is going to open down. You can use your calculator to help you get the other points. So in your y1, go ahead and enter -2x squared plus 4x plus 5 and graph it. So you should be able to see what it looks like. Press second graph to look at the table, and again, you know what area you're focusing on because you know where the vertex is. So if I look at the t-chart that's around 1, 7, then I've got 2, 5, 3, -1, on the above points. On the below points, I've got 0, 5, and -1, -1. So I'm going to plot all those points. So -1, -1 would be here. 0, 5, 2, 5, and 3, -1. Again, this is a solid parabola we decided, so when I connect it, I make it solid. So now I just need to do my shading. So I need to pick a point. And I always write this out, and you should too, so that when I look at your work, if you don't get it right, I can see what you did. So we want to pick a point that's inside the parabola. If 0, 0 is inside, pick it, because it's the easiest thing to plug in. If it's not, then pick something else, but you want to pick small numbers. They're easier to plug in. So I'm going to pick 0, 0, and I'm going to plug it back in to this equation. So I'm asking, is 0 greater than or equal to -2 times 0 squared plus 4 times 0 plus 5. So in this becomes 0 and so does this. So on the right, I've just got 5. So we're just deciding, is 0 greater than or equal to 5? And if we look at that, hopefully we can say no, 0 is not greater than or equal to 5. So this is a false statement. So when you have a false statement for the point you picked inside, that means we are going to shade outside. So our shading then for this inequality should be out here. All right, so hopefully that doesn't seem too rough. I'm just kind of adding one step with the shading as well as just the solid or dashed. So now we're going to look at the second half of the first learning goal, that we also want to be able to graph systems of inequalities. So that just means we've got more than one. So again, if we're graphing a system, remember the solution is the overlap of the shaded region. So I'm going to do what I just did in A twice with these two functions, and then my answer is going to be in the overlap. So I'm going to draw a line here to separate my work because it's going to get everywhere. So first one here, this is a standard form equation. I know that this one is going to be solid. I also know it's going to open down. Opposite of b over 2a. In this case, there is no b value because there's no plain x term. So it's opposite of 0 over 2 times -1, which is just 0. So when I plug 0 in to find my y-coordinate, -0 squared is 0, plus 8 is 8. So 0, 8 is going to be my vertex for that first solid open down parabola. Again, you can use your graphing calculator to help you come up with the rest of the t-chart around your vertex. So plug in your -x squared plus 8. And look at your table. We've got -1, 7 right around it, and -2, positive 4. So then we've also got 1, 7, and 2, 4. So we'll graph those. -2, positive 4 would be right here. And then we've got -1, 7 right up here. 0, 8 way up at the top. And then 1, 7, and 2, 4. This is a solid parabola. So we will go ahead and connect it. And then for my shading on this one, again, you want to pick a point that's inside. So we're lucky this time 0, 0 happens to be inside. So we're going to pick that and plug it in. So if I plug in 0, 0, I get 0 is less than or equal to -0 plus 8. So 0 is less than or equal to 8, so that means this is a true statement, and I'm going to shade inside for this parabola. So now I'm going to move on to my second parabola here, right here, and this one is going to be a dashed parabola because it does not have an equals with its symbol. It's also in standard form, so opposite of b over 2 times a. So -2 over +2 gives me -1. then I need to plug that in. So negative 1 squared plus 2 times negative 1 minus 6. So 1 minus 2 is negative 1 minus 6 gives me negative 7. So that gives me an area to focus on for my t-chart. So plug that into your calculator. X squared plus 2x minus 6, and go to your table so we can see where the vertex is. Scroll till you've got it kind of in the middle so you can get your other points around it. So just below it we've got negative 2, negative 6, and negative 3, negative 3. Then above it we've got 0, negative 6, and 1, negative 3. So I'm going to graph those. So negative 3 would be right here. Negative 2, negative 6. Then negative 1, negative 7, 0, negative 6, and 1, negative 3. Now this is a dashed parabola, so when you connect it, make sure that you indicate clearly that this is dashed. So not connected with solid lines. There we go. And then if we pick a point inside 0, 0, we are just really lucking out today because that happens to be inside of this one as well. So when I pick 0, 0 and plug it in, I get 0 is greater than 0 squared plus 0 minus 6. So is 0 greater than negative 6? Yes, it is. So that means we are going to shade inside that as well. So if I look at my two shadings, remember that the answer is going to be where my green shading and my red shading overlap. So I'm going to use blue to show where your answer should be. So the part that is inside, that is the overlap of both of those, would be right in here, the space between. All right, so that wraps up our first learning goal. We graphed quadratic inequality, we graphed a system of inequalities where there were two variables, so that means we had y and x's. Now we need to also be able to solve a single quadratic inequality graphically. So that means there is no y, it's just an x. And there is an algebraic way to solve this, but it's pretty complicated. Graphically is much, much less work. So here are our steps. And again, this is a single, meaning that there is no y variable in the problem. So we've got x squared plus x minus 2 less than 0. First step is to get all terms on one side. Well, that's already done for us. So we're going to graph the parabola in our graphing calculator as if there were a y, but of course there really is not. So we're going to graph x squared plus x minus 2. And when you are graphing it, this you do not need to graph the exact vertex and exact points. This is going to be a sketch only. So I quickly look at my graphing calculator and I say, okay, this looks something like that. And that's all we need. So we just need the sketch. Step 2 is to find the zeros. So we can do that in our graphing calculator. Remember that that's in your second trace menu. So second trace, choice 2. So second trace, press 2 to find the 0. And remember there's 2 of them, so you're going to have to do it twice. So left bound, remember that when it says left bound, if you're finding this 0 right here, left bound is up here. So tell it yes when you're left bound, then right bound would be, get the blinky there, and then tell it yes to guess. And it should tell you that that 0 is when x is negative 2. So then we need to find our other 0. So we go to second trace, choice 2 again. But this time on this side, remember we want x values to the left would be over here. So we put the blinky over there for left bound, and then we move it over here for right bound, and then tell it yes by pressing enter so it'll guess. And then that's x equals 1. So you can see again my sketch is not real accurate, but that's okay because we don't really need the sketch for anything other than to look at it. So we've got our zeros. Now what we're going to do in step 3 is we are actually solving this visually. So we are trying to find the x values that correspond with the part of the parabola that is above or below the x-axis. So I look at this symbol, and that tells me I want less than, which means I want the part of the parabola below the x-axis. So below the x-axis here, the part of the parabola that is there, if I can use a different color, would be this part right here. So it's the loop of the parabola that satisfies this inequality. The loop of the parabola is what is less than 0. So if the answer to the inequality is the loop, then your answer is going to be a sandwich. And what do you sandwich x between? You sandwich it between the two zeros. So since it was the loop, I know I'm going to make a sandwich, and I'm going to sandwich it between my two zeros. So the solution here is that x is between -2 and +1. Now the only thing that people sometimes forget here is that you have to make this symbol match these ones, not less than greater than, but you have to make a match in the sense that if this has an equals, then these would. Since this doesn't, then these don't. But again, the part of the parabola that was less than 0 was this part here. Down below the axis, that's the loop. So that's the part that's between the zeros, so my answer is a sandwich. If it had been the ends of the parabola, so this part and this part, then the answer would be a disjunction, which is the ORs. All right, let's try this one more time to make sure you've got it. So first step, get all terms to one side and graph the parabola. So that means I need to add the 41 over. So I've got 3x squared plus 24x plus 41 is greater than or equal to 0. And again, I'm just using my graphing calculator. You don't need to find the vertex here. This is just going to be a rough sketch. So when I graph it, I get something that looks sort of like this. So I've got my sketch. Now I need to find my zeros. So I've got 2 of them right here, right here. Go to second trace, choice 2. So on this 0, left is going to be here. And I've got to get my blinky in the right place. So move your little blinking cursor so that it is left bound of the left side 0. Press enter. Then it says right bound, so that means move it so that it's over here. This would be right bound. Press enter again. Then press enter a third time for it to guess. And it tells us that x equals -5.527525. So we're going to round that to the nearest tenth, let's say. -5.5. Now I need to find my other zeros. So I go back to second trace, choice 2. This time, when it says left bound, my cursor is going to go right there. I'm going to press enter. Then when it says right bound, I'm going to move my cursor up there, press enter, then press it a third time for it to guess, and that is saying that x equals -2.472. So again, we'll round that in this case to the nearest tenth, so about -2.5. All right, so now that we know where our zeros are, we have to visually solve the problem. So we look at our equation, And this is a greater than or equal to symbol. So we want to find the part of the parabola that is above, since it's a greater than, the x-axis. So the part of the parabola that is above are these ends. So if it's the ends of the parabola, the answer is going to be a disjunction, an or. So you use these two values no matter what, but this one's going to be an or. So either x is less than this 0, so x less than or equal to negative 5.5, or x is greater than or equal to, because that's this part of the parabola when x is bigger than the 0, which is negative 2.5. So if it's the ends, you're going to write a disjunction and or with your two zeros. If it's the loop of the parabola, the between, you're going to write a sandwich with the zeros. All right, and that is it.